Now we're gonna discuss about circular motion. If none here, let me explain to you. There are three mathematical quantities that will be of primary interest to us as we analyze the motion of objects in circles. These three quantities are speed, acceleration and force. The speed of an object moving in a circle is given by the following equation. The acceleration of an object moving in a circle can be determined by either two of the following equations. The equation of the acceleration is derived from the equation of the speed by the substitution of the expression. The net force, Fnet, acting upon an object moving in circular motion is directed inwards. While there may be more than one force acting upon the object, the vector sum of all of them should add up to the net force. Do you have an idea about net force / Let me discuss to you. Net force is the overall force acting on an object. In order to calculate the net force, the body is isolated and interactions with the environment or other constraints are represented as forces and torques in a free body diagram. The net force is related to the acceleration of the object, as is always the case, and is thus given by the following three equations. The equations in the middle and on the right are derived from the equation on the left by the substitution of the expressions for acceleration. This set of circular motion equations can be used in two ways. As a recipe for algebraic problem solving in order to solve for an unknown quantity. As a guide to thinking about how an alteration in one quantity would affect a second quantity. These two ways are illustrated next. Now I will discuss to you about equation as a guide thinking. An equation expresses a mathematical relationship between the quantities present in that equation. For instance, the equation for Newton's second law identifies how acceleration is related to the net force and the mass of an object. An equation expresses a mathematical relationship between the quantities present in that equation. For instance, the equation for Newton's second law identifies how acceleration is related to the net force and the mass of an object. This equation shows that the net force required for an object to move in a circle is directly proportional to the square of the speed of the object. For a constant mass and radius, the Fnet is proportional to the speed too. Now let's proceed on how the equation as a problem solving. The mathematical equations presented above for the motion of objects in circles can be used to solve circular motion problems in which an unknown quantity must be determined. The process of solving a circular motion problem is much like any other problem in physics class. The process involves a careful reading of the problem, the identification of the known and required information in variable form, the selection of the relevant equations, substitution of known values into the equation, and finally algebraic manipulation of the equation to determine the answer.
Created using Powtoon.